Okay, so I moved over to the other whiteboard. Isn't that exciting? Now, to sketch this, and when I say sketch, it means you do not have to care about using a ruler. You don't have to get it all that precise. You don't have to worry about the scale too much, all right? Sometimes you don't even have numbers in a sketch. You just boom, boom, just sketch out the shape. In this case, I do have some numbers, and so I can at least estimate it. It says for the position time graph, we know that, I'm pointing to the other board, which is over there. That's where you have the information. For the first 2.5 hours, this is time on the x-axis here. For the first 2.5 hours, from here to here, she goes from her starting position, and then she travels 250 kilometers to the north. I'm going to make north positive, so I'm going to go up on this. So she goes from here to here. She travels from that point to that point. All right. So she starts out at 0 hours at her initial position. So at 0 hours, the time when the stopwatch starts, she's here, and that's her position. When that time is 0, that's her position. After 2.5 hours, she ends up at 250 kilometers. So she's about right there, okay? And she travels at a constant rate, a constant velocity. So that is a straight line. A straight line on a position time graph represents constant velocity. The slope of this line, 250 divided by 2.5, is 100. And that's her velocity. Her velocity for the first segment, for the first 2.5 hours, is a constant a constant 100 kilometers per hour. I'm getting a different color here. So if I go up on the velocity, well, it's a constant 100 kilometers per hour. So I'm going to make this, what are the other numbers I need here? Okay, so let's make this, that's 50 kilometers per hour, and that would be 100 kilometers per hour. 250 divided by 2.5 is 100 kilometers per hour. We already knew that because that was given in the original problem, that she was traveling 100 kilometers per hour north. I'll make it positive because that's a positive slope. So it's a positive 100, and I also said that north is positive. Therefore, here's 2.5 hours, and this is a constant, unchanging 100 kilometers per hour. So it's 100 kilometers per hour at any time along here. At half an hour, 1 hour, 1.5 hours, 2 hours, 2.5 hours, it's a constant 100 kilometers per hour. Well, then for the next 3/4 of an hour, she's at rest. She doesn't move. Now, don't drop down here. She doesn't go from the 250 kilometer position and end up back here. You can't get there without moving. She's here and then she stops moving. So she stays there. But don't forget that time marches on even when you're not moving. So this is, on the y-axis, that's position. Her position doesn't change. She stays at 250 as the time marches on. So that's for 3/4 of an hour. That's going to go here to 3 1/4. So to that point right around here. She's at 2.5 hours, and then for another 3/4, and 2.5 plus 3/4 is 3 1/4. She stands still. All right. She's not moving. She's staying here at 250 kilometers. She stays there, has a picnic. Okay. The whole time she's 250 kilometers away from where she started for that whole time period. Notice that slope is 0, and the slope of a velocity time graph of a position time graph is the velocity. And also you know that the velocity is 0 because it says so. So 0 for velocity is down here at 0. So during that time period, that's 0. Okay, that's 0. You can connect these if you want to. And then the next part says that she goes south for 100 kilometers. Well, she's at 250 kilometers. She goes south, and this happens over a period of 2 hours. So it can go from here, that's where she is when she starts moving, And then that's 3.25. And for 2 hours, that's from here to here, right? 3.25 plus 2 is 5.25 hours. But she doesn't end up down here. She only goes 100 kilometers. She's at 250 kilometers. She's going to go 100 kilometers, which will take her down to 150. So that's about there, right? Okay, that should be at 150. So that's that second time segment. The slope of this graph should be 50, and notice it's negative. If I made north positive, then south will be negative. She's going in a different direction. Therefore, for the last 2 hours, she's traveling at 50 kilometers per hour south, which I'm going to make negative because I need to come up with a sign convention to be able to plot it mathematically or graphically. All right, so this is from 3.25 hours to 5.25 hours, and right below these numbers. And it's down here. Whoopsies, that should be a straight horizontal line coming right below that. And there you go. That didn't come out too well right there, did it? There you go. Constant 100 kilometers per hour for that first segment. Constant 0 kilometers per hour for when she's at rest. And constant negative 50 kilometers per hour for the third segment. Okay, again, these slopes represent these numbers. 100, slope of 100. 0, 0, because that's 0, 0, 0, because that has a slope of 0. Negative 50, that has a slope of negative 50. One last thing, I did not ask this, but just to point it out, remember that the slope of this graph, the area of this graph, the area of a velocity time graph, represents displacement. So delta x1 would be, well, this is a rectangle. That's 100 kilometers times, because it's a rectangle, you multiply length times width. Okay, that's 100. That's 2.5 times 2 and that would give you so that's 100 kilometers per hour, excuse me, that's velocity, right? 100 kilometers per hour times 2.5 hours would give you 250 kilometers, that's her displacement, which is exactly what she did. She went from 0 to 250. This part would have a displacement of 0. She didn't go anywhere. The area of this is 0, all right? Length times width is just a line, it's not a box. So that's a delta x for 2 of 0. That makes sense. She's at rest. And the area of this last one, delta x3, would be negative 50 times 2, which is negative 100 kilometers. Now that again is a displacement, not a position. She displaced from positive 250, she displaced by negative 100. So she went from positive 250 minus 100, put her at 150. Okay. Area gives you displacement. Area of a velocity time graph gives you displacement. Remember that the slopes of these things, the slope of the position time graph gives you velocity. Okay. Slope of a position time graph gives you velocity. Area of a velocity time graph gives you change in position, displacement. All right, we're done.